are going to present the Einstein Logic Puzzle to you. The Einstein Logic Puzzle can be easily found on the internet. When Einstein came up with this puzzle, he claimed that only 1 out of 50 people are intelligent enough to solve it. While the truth of that remains unknown, we are going to learn how to solve it today. We are given 5 sets to start with, each representing a house. The 5 houses are in a row and numbered from our left to right. We are then given 5 categories. They are nationality, house color, pet, beverage, and cigarette brand. Each set contains 1 element from each of this category, and each element is to be used only once. There are 15 premises given to us to help us fill in the blanks. Some of these are direct clues, while others require us to make use of logical reasoning. Do not worry if you are not able to remember all 15 premises. We will be inserting them throughout the video whenever we are using them. Given all this, our task is to find out which set the pet fish belongs to. The main formula that we will be using is the following. For all A, S, and B, given that A is an element of set S and A is not in a set that does not include B, A equals B. This is the concept of elimination. Now that we have so many different categories and sets and elements, you may find that it is rather hard to approach this puzzle. Hence, we will be representing the problem and concepts used in the explanation with a giant table and graphics. We first sieve out the direct clues given in the premises. They are 8. The man living in the middle house drinks milk. 9. The Norwegian lives in the first house. 14. The Norwegian lives next to the blue house. We can put these direct clues directly into the table. Next, we look at clue 4. It states that the green house is on the left of the white house. Let X be the house number of the green house. Given that the second house is blue, X cannot be 2. From clue 4, the number of the white house is implied to be X plus 1. Given this implication relation, and that the second house is blue, X cannot be 5 and X cannot be 1. Given clue 5, if the number of the green house is X, then coffee must belong to the set that represents the green house. Given this, and that the beverage in house 3 is milk, X cannot be 3. We now apply the elimination formula. Since X is in a set of 1, 2, 3, 4, and 5, and X cannot be 1, 2, 3, or 5, then X must be 4. Next, we look at clue 1. We are given that the Brit lives in the red house. Let X be the number of the house that Brit stays in. Then house X is red. We know that the second house is blue, the fourth house is green, and the fifth house is white. So X cannot be 2, 4, and 5. Since the Norwegian lives in the first house, X cannot be 1. By elimination, X must be 3. The only color left is purple, hence we put it in for house 1. Clue 7 states that the owner of the purple house smokes Dunhill. Now that we know the first house is purple, we can put in the element Dunhill for the first house. Clue 11 states that the man who keeps the horse lives next to the man who smokes Dunhill. Hence we know that the pet horse belongs to the second house. At this point in time, you may find that we are stuck with a whole list of indirect clues which require application of our logical reasoning. Hence, we will put in different possibilities for each entry in the sets in blue. From clue 10, we know that the man who smokes blend lives next to the one who keeps cats. Clue 15 also tells us that the man who smokes blend has a neighbor who drinks water. Let x be the number of the house which owner smokes blend. X cannot be 1 because the only neighbor of house 1 keeps a horse. X also cannot be 5 because the only neighbor of house 5 drinks coffee. Therefore, by elimination, X can only be 2, 3 or 4. We put in lines to indicate joint possibilities where the different elements must occur together. This will help us see the connections among possibilities, which act as a restriction to how we put in the different elements. From clue 3, we know that the Dane drinks tea. Let X be the number of the Dane's house. The owners of houses 3 and 4 drink milk and coffee respectively, so X cannot be 3 and 4. The owners of house 1 and 3 are Norwegian and Brit respectively, so X cannot be 3. Therefore, X can only be 2 or 5. From clues 2, 6 and 12, we know that the Swedish has a dog, the person who smokes Palmer rears birds, and the owner who smokes camel drinks beer. So we put in more possibilities using the same logic. Bear in mind that we have not put in the elements German and Marlboro. From the table, we can see that water is the only possible beverage for house 1. To explain this mathematically, we let X be the house owner who smokes blend. If the house number of the set with blend is X, then the house number of the set with water and the set with cat must be X minus 1 or X plus 1. Given that water belongs to the first house, then X must be 2. We must then strike out the possibility of camel under house 2, and given its implication relation with beer, beer must also be struck out. Therefore, camel and beer must be in the set representing house 5. Dane and tea in house 2, and cat in either house 1 or 3. We now modify the table accordingly. Clue 13 states that the German smokes Marlboro. Let the German be X. This implies that Marlboro is in house X. Given this and that the Norwegian, Dane and Brit stays in houses 1, 2 and 3 respectively, and Dunhill, Blend and Camel belong to houses 1, 2, 5 respectively, the German must stay in house 4. This then implies that Marlboro belongs to house 4. In addition, Sweet and Dog belongs to house 5, and Palmer and Bird belongs to house 3. Given all this, we now know that the cat belongs to house 1. We can now conclude that the pet fish belongs to house 4. The method of solving Einstein's logic puzzle is not an exclusive method. In fact, it can be applied on various other logic puzzles with similar premises. One example is the game Sudoku. Just as how we have direct clues in the Einstein's logic puzzle that we can immediately use, there are some entries in Sudoku that we can immediately fill in. The pre-given numbers, combined with the rules, act as direct clues in this case. On the other hand, some clues only allow us to slowly eliminate possibilities that can be entered in. This can be done by cross-referencing clues with others. Another example is Cluedo. Cluedo requires the player to sort out clues containing sets of places, weapons, and suspects in order to find the murderer, weapon used, and the crime scene. Clues can be categorized into two types: the direct clues given to us in the form of clue cards, and the other player's guesses, which can give us indirect clues using our own deduction.